Welcome to Midnight Science, where tonight we drift far past the edge of the known universe into a quiet place where light is older than almost everything you have ever touched. There are galaxies out there that should not be there yet. The James Webb Telescope looked back toward the beginning of time and found bright, fully formed worlds, glowing where there should have been only darkness. Tonight we wander softly among them. If these gentle journeys help you fall asleep, a like and a subscribe help others find this calm corner of the night too. And before we begin, tell me softly in the comments, where are you listening from, and what hour has it become where you are? Let us begin where everything began. Not with a sound, because there was no one to hear it, and not with a flash, because there was no eye to catch it. Let us begin with the dark. Close your eyes and let the room around you soften. Imagine drifting backward, gently, past every year you have lived, past the long history of the world, past the age of the dinosaurs, past the slow turning of the first oceans. Keep going, past the birth of the earth, past the birth of the Sunday. Keep drifting until even the oldest stars you know have not yet been born. There is no rush in this journey. We have all the time in the universe, and tonight that is almost literally true. We are traveling back more than 13 billion years to a moment when the universe was very young and very small and astonishingly simple. There is nothing here that you would recognize. No planets, no stars, no galaxies turning slowly in the black. There is only a soft, warm fog spread evenly in every direction, filling all of space with a gentle and featureless glow. This fog is mostly hydrogen, the lightest and simplest thing there is. It is the raw material from which everything else will one day be made. Every star, every world, every living thing, all of it is waiting here, dissolved into this quiet haze. But for now, nothing has happened yet. Nothing has gathered. Nothing has begun to shine. Scientists have a name for this long, still chapter. They call it the cosmic dark ages, and it is exactly what it sounds like. A stretch of time when the universe held no light that could travel freely, no beacons, no fires in the dark. The word dark can sound lonely, even a little frightening, but there is nothing to fear here. This darkness is not empty in the way an abandoned house is empty. It is full. It is patient. It is the deep, even quiet of a world that has not yet woken up. Let yourself rest in that quiet for a moment. Imagine a darkness so complete and so smooth that it has no edges and no center. A darkness that is the same wherever you turn. There is a kind of peace in it. The peace of something that is whole and waiting and unhurried. In these early times, the universe was far smaller than it is now, and far warmer. Everything was packed more closely together. The hydrogen fog was thick, and it had a strange and important quality. It was opaque. Light could not move through it cleanly. Any glimmer that tried to cross this fog would be caught and scattered, absorbed and muffled, the way a lamp is swallowed by a dense bank of mist on a cold night. So even if there had been something shining in those first ages, and there was not yet, its light could not have reached far. The young universe kept its own counsel. It held its breath. And so the dark ages drifted on. Not for a year, or 1,000 years, or 1,000,000. They lasted for a very long time. Hundreds of millions of years. An unimaginable patience folded into the fabric of the early cosmos. Through all of it, the fog simply waited, cooling slowly as the universe expanded and stretched and gave itself more room. cooling, thinning, settling, like a held breath being let go in the slowest possible way. Now, here is the gentle question that scientists have carried for a long time. If the early universe was only this smooth, simple fog, then how did we get from there to here? How did featureless haze become galaxies and stars and warm planets with oceans and music and someone, somewhere, lying quietly in the dark and listening to a voice tell this story? How does nothing in particular become everything we know? The answer they have built over many careful decades is a story of slowness, a story of gathering. And tonight, before we travel any further, it helps to understand the story as it was meant to be told, because the wonder of where we are going lies in how it bends that story out of shape. Here is the rule, as cosmologists came to understand it. In the beginning, the fog was not perfectly even. There were the faintest ripples in it, places where the gas was a little denser, regions where matter leaned ever so slightly closer together. These were tiny imperfections, almost nothing at all, whispers of difference in an otherwise smooth sea. But almost nothing is not the same as nothing. And gravity, the patient sculptor, has all the time in the world. Where matter was a little denser, gravity pulled a little harder. And where it pulled a little harder, more matter drifted in. And where more matter drifted in, the pull grew stronger still. Slowly, over enormous spans of time, these gentle ripples deepened into hollows, and the hollows gathered the surrounding fog, and the universe began, very gradually, to grow lumpy, to grow structure, to grow the first faint architecture from which everything else would one day hang. But there is more to the rule than the fog alone. The matter we can see, the hydrogen and the things made from it, was not working by itself. According to the careful story, it was guided by something unseen, a second kind of matter, invisible and silent, that does not shine and cannot be touched, that passes through ordinary stuff like a breeze through an open window. Scientists call it dark matter, and though no one has ever held a piece of it, its gentle gravity seems to shape the whole cosmos from behind the scenes. In this story, the dark matter moved first. It gathered into vast, invisible clouds. Enormous, shapeless halos spread across the early universe, soft mountains of gravity with nothing visible inside them. And only then, drawn down into these invisible valleys, did the ordinary fog begin to pool. The hydrogen sank into the dark matter halos the way rainwater settles into the low places of a landscape after a long, soft storm. The unseen scaffolding came first. The visible universe filled it in afterward. This is the heart of the rule. Galaxies were meant to be slow. They were meant to be assembled, not born whole. Brick by patient brick, halo by halo, the universe was supposed to build them gradually, gathering gas, lighting its first dim stars, merging small clumps into larger ones over hundreds of millions of years. The grand spirals and great glowing islands of stars we see today were imagined as the end of a long, unhurried construction, the work of ages, the product of deep cosmic time spent slowly and carefully. Hold that gently in your mind. The early universe was not supposed to be in a hurry. It was supposed to begin small and dim and modest. The first true galaxies, when they finally appeared, were expected to be little things, faint, sparse, barely there, pale smudges of newborn light, just beginning the long work of becoming something grand. Anything large, anything bright, anything heavy and mature and fully formed, all of that was meant to come much later after the universe had taken its time. That was the rule. That was the careful, beautiful story. And yet, keep those two small words somewhere soft and close as we travel on, because the whole of tonight rests upon them. The universe, it seems, did not always read the story we wrote for it. Somewhere out in the deep dark, in the very first chapters of cosmic time, there appears to be something that should not be there yet. Something too bright, too soon. Something that does not fit the patient timeline of slow gathering and gradual growth. We will come to it gently, in time. For now, simply let the possibility rest at the edge of your thoughts, like a light glimpsed far off across dark water. This whole careful account, the slow ripples, the invisible halos, the unhurried assembly of galaxies, all of it belongs to a larger picture that scientists have trusted for a long time. It has a name, though the name matters less than the feeling of it. They call it the standard model of cosmology. Sometimes they describe it by its ingredients: dark energy and cold dark matter, the mysterious force that stretches the universe wider and wider, and the unseen matter that quietly shapes it from within. It is not a wild guess. It is one of the great achievements of human thought, a story stitched together from countless measurements and long nights of observation, refined and tested across many decades. It has explained so much, and explained it so well, that for a long time it stood almost unquestioned, the trusted map by which we understood the deep past. When scientists imagined the dark ages and the slow dawn of the first galaxies, this was the picture they were drawing from. This was the rule the universe was supposed to follow. For now, let that be enough. Let the universe be young and dark and simple. Let the fog drift and cool. Let the invisible halos gather in their unhurried way, waiting for the first light to pool inside them. Let the great story stand, careful and complete, exactly as it was written. We are at the very beginning, in the deep and gentle dark, in the long quiet before anything has begun to shine. There is nothing here to trouble you, only a patient universe, holding its breath, waiting to wake, and somewhere ahead of us, hidden in that first light, a small surprise is waiting too. There is something we must understand before we travel any further, and it is one of the most beautiful ideas that human beings have ever stumbled upon. So let us take it slowly, the way you might turn a smooth stone over in your hand in the last soft minutes before sleep. When you look up at the night sky, you are not seeing the stars as they are. You are seeing them as they were. The light that touches your eyes tonight has been traveling for a very long time, and it left its source long ago. The star may have changed since then. It may have flared, or dimmed, or even quietly died. But its light is still arriving, still carrying the message it set out with, faithful across all that distance. To look out into space is to look back into time. The two are the same gesture. There is no way to see something far away as it is right now. You can only ever see how it used to be. Let that settle for a moment, because it is gentler and stranger than it first appears. The light from the sun takes about 8 minutes to reach us, so we always see the sun as it looked 8 minutes ago. The light from the next nearest star takes years, and the light from distant galaxies takes millions upon millions of years, so that when we gaze at them, we are gazing deep into their past, watching events that finished an unthinkable time ago. The further away a thing is, the older the news it brings. Now follow this thought outward, gently, as far as it will go. If looking further means looking further back, then somewhere out there, at the very edge of how far we can see, lies the beginning itself. The deeper we peer into space, the closer we drift to the young universe, to the fog, to the dark ages, to the first faint stirrings of light. The most distant light of all would be the oldest light of all. It would have set out when the cosmos was an infant, and it would have been traveling toward us patiently ever since. This is the quiet miracle at the heart of tonight. The early universe is not entirely lost to us. It did not vanish. Its light is still on its way, still crossing the dark, arriving even now, faint and ancient and almost impossibly old. We do not need a machine that travels through time. We only need eyes patient enough and sensitive enough to catch the oldest light as it finally completes its long journey home. But catching that light is not simple, and the reason why is one of the loveliest facts in all of science. The universe is not standing still, it is expanding. Space itself is gently stretching, growing wider in every direction, carrying the galaxies slowly apart from one another like raisins drifting outward in a loaf of bread as it rises. This expansion has been happening for the whole life of the cosmos, and it does something remarkable to light as it travels. Imagine a wave of light setting out from a young galaxy long ago. As that light crosses the vast and growing distance toward us, the space it is moving through is stretching beneath it. And as space stretches, the light stretches too. Its waves are pulled longer and longer, drawn out gently across billions of years of travel. Now, the length of a light wave is what gives it its color. Shorter waves look blue, longer waves look red. So as ancient light is stretched by the expanding universe, its color slides slowly toward the red end of things. Astronomers call this redshift, and it is, in a way, the universe quietly aging the light it carries. Picture it almost like a sound. Think of the long, low note a distant train leaves behind as it moves away from you, the way the pitch seems to fall and soften as the distance grows. Light does something similar across the gulf of space and time. The further it has traveled, and the longer the universe has been stretching beneath it, the more its waves are drawn out, the redder and lower it becomes. The oldest light is the most stretched of all. The most distant galaxies are the most reddened. Redshift becomes a kind of clock and a kind of measuring stick, telling us not only how far a thing is, but how far back. And here is where the journey grows delicate. If you stretch light far enough, it slips past red altogether. It is drawn out beyond the colors the human eye can see, into a kind of light we cannot perceive at all, a warm, invisible glow that lies just past the edge of vision. This is infrared light. It is all around us, in the heat of a sleeping body, in the warmth rising from sun-touched stone, but our eyes were never built to see it. And the most ancient light in the universe, the light from the very first galaxies, has been stretched so severely by so many billions of years of expansion that almost all of it has slipped into this infrared, hidden just beyond the reach of ordinary sight. This is why, for so long, the earliest chapters of the universe stayed dark to us. We had wonderful telescopes. We had Hubble, that patient eye above the Earth, which gave us images of breathtaking depth and showed us galaxies we had never dreamed of. But Hubble saw mostly the light our own eyes can see, and a little beyond. It could not follow the oldest light all the way into the deep infrared where it had gone to hide. The first galaxies were calling out to us. We simply did not yet have an instrument tuned to hear their particular, reddened, ancient whisper. To reach them, we needed a different kind of telescope, one built specifically to gather infrared light, to feel that faint warmth from the dawn of time. And to do that, it would have to be extraordinarily large, with a great golden mirror to collect every scarce and precious photon. It would have to be kept colder than almost anything, shielded and chilled, because warmth itself glows in the infrared, and any heat of its own would drown out the delicate signals it was straining to catch. And it could not sit near the warm and glowing earth. It would need to drift far out into the cold and quiet dark, 1,000,000 miles away, where it could stare into the deep without distraction. This is the James Webb Space Telescope, a great unfolded mirror of gold, floating in the cold far from home, holding perfectly still and gazing into the oldest dark with an eye tuned precisely to the kind of light no human has ever seen unaided. It was built, more than anything, to do one thing: to catch the most ancient light in the universe, the reddened, stretched, infrared whisper of the very first galaxies, and to finally let us look upon the dawn. Let us pause and feel the scale of what that means, because the numbers alone are too large to hold, and they deserve to be made gentle. When Webb looks at the most distant galaxies, the light it gathers has been traveling for more than 13 billion years. Think of that against a single human life. If you could somehow count 1 year for every second, marking off the age of this light one tick at a time, you would be counting for more than 4 centuries without rest before you reached the end. This light left its source before the Earth existed, before the Sun existed, before nearly everything you could name. It crossed an ocean of darkness so wide that the word distance begins to lose its meaning. And at the end of all that travel, it landed, softly, on a mirror of gold. When that light finally arrives, it is unimaginably faint, so faint that the telescope must stare at a single tiny patch of seemingly empty sky for hours, sometimes for many hours, simply gathering enough of these ancient and exhausted photons to form a picture at all. Picture the patience of that. A great eye in the cold dark, holding its gaze on one small square of nothing, waiting, collecting light one weary particle at a time, like catching rain in a cup, one slow drop at a time, until at last there is enough to see by. And so, when astronomers first turned this telescope toward the deep, they did so with a clear expectation in their minds. Remember the rule, remember the careful story. The early universe was supposed to be modest. The first galaxies were meant to be small, faint, sparse, barely there. So when Webb began to peer into those ancient distances, into the era just a few 100 million years after the beginning, the astronomers expected to find pale and timid smudges. Little newborn things, dim and unfinished, just beginning the long, slow work of becoming. They were looking into the cradle of the cosmos, and they expected to find it quiet. They pointed the golden mirror at the dark. They held it there. They gathered the ancient light, drop by patient drop, and they began, at last, to look upon the dawn of everything. And almost at once, something was not quite right. The first images came in, carrying their messages from more than 13 billion years ago, and the faint, timid smudges the astronomers had braced themselves for were not entirely what looked back at them. There was light out there in the deep, in the very first chapters, where there was supposed to be only the gentlest beginning, and some of that light seemed, somehow, to be more than it should be. Too clear, too soon. The oldest light in the universe had finally completed its long journey home, and it had brought a surprise. Let us give the surprise a name. Names matter, even out here at the edge of everything, because a name is how we begin to love a thing, how we hold it close enough to wonder about it. And the first of tonight's impossible lights carries a name that sounds less like poetry and more like a quiet code, a string of letters and numbers murmured by the people who found it. It is called JADES GSZ 130. Let the strangeness of that name wash over you without worry. By the time we part tonight, it will feel almost familiar, almost like a friend. It was found in the year 2022, in the very first season of the Great Golden Telescope's gaze. Astronomers had gathered together for a long and careful survey, a patient sweep of one small region of the heavens, and they had given that effort a name as well, the JADES Survey, the deep extragalactic survey that lent its letters to the galaxy itself. They were not glancing carelessly across the whole sky. They were doing the opposite. They were staring, long and unblinking, at a single small and well-known patch of darkness, gathering its faint light hour after hour, drop by ancient drop. The patch of sky they chose lies in the direction of a constellation called Fornax, a quiet and modest grouping of stars in the southern heavens, named long ago for a furnace. It is not a famous constellation. It holds no bright and storied stars that sailors steered by, no shape that ancient people wove great myths around. It is an unassuming corner of the night, and yet, in the direction of that gentle furnace, hidden far behind its scattered foreground stars, lay something that would unsettle the careful story of the cosmos. Here is a detail worth resting on, because it makes the discovery even more tender. This was not unexplored sky. This particular region had been studied before, looked at and looked at again across the years by earlier telescopes, including the patient eye of Hubble. Astronomers knew this stretch of darkness well. They had mapped its faint smudges and catalogued its dim glimmers. They thought they understood what lived there. And then a new and more sensitive eye turned toward the same familiar place, an eye tuned to the deep infrared, and saw something that had always been there but had never been seen. The light had been arriving all along. We simply had not been able to catch it. Sit with that for a moment. There are things in this universe that have been waiting patiently in plain sight, present and shining, needing only the right kind of looking to be found at last. So what exactly did they find? To understand it, we return to the gentle idea of redshift, the stretching of ancient light as the universe expands beneath it. Remember that the further light has traveled, the more it has been drawn out, the redder and more reddened it becomes, until the oldest light of all slips deep into the invisible infrared. Astronomers measure this stretching with a single number. They call it the redshift, and they mark it with the letter Z. The larger that number, the more the light has been stretched, the further it has come, and the further back in time we are looking. For this galaxy, that number is 13.2, and for most of us, a figure like that floats by without meaning, just digits drifting past in the dark. So let us turn it slowly into something we can almost touch. A redshift of 13.2 is enormous. It is among the largest ever measured. It means this light has been stretched so severely, drawn out so far by so many billions of years of expansion, that it has crossed nearly the entire history of the universe to reach us. And when astronomers translate that stretching back into time, they arrive at a number that takes the breath away gently. We are seeing this galaxy as it looked only about 320 to 330 million years after the very beginning, after the Big Bang, after the first moment of everything. Let that rest. Out of the whole life of the cosmos, more than 13.5 billion years of it, this light shows us a moment astonishingly close to the start. The universe was barely more than an infant. The fog of the Dark Ages had only just begun to lift. By every expectation in the careful story, this was a time of faint and modest beginnings, of pale, unfinished things, just learning how to shine. And yet here, already, was a galaxy, formed and glowing, sending its light out into the dark. There is a way to feel a number like 320 million years that makes it suddenly intimate, and I want to share it with you softly, because it is one of the most quietly astonishing comparisons in all of this. We tend to imagine the early universe as impossibly, almost meaninglessly old, a span so vast that it has nothing to do with us. But consider this. Sharks have swum in the oceans of the earth for something like 400 million years, longer than there have been trees that flower, longer than there have been dinosaurs. The shark is one of the oldest enduring things our world has made, and yet this galaxy, JADESGS 130, glowing in the deep, is only a little younger from our point of view than the entire span of time that sharks have existed on Earth. Let that turn over gently in your mind. The whole long age of sharks, that immense and ancient story, is roughly the same size as the gap between the Big Bang and this galaxy's light. The early universe is not as unreachably distant as it sounds. It is old in a way we can almost hold. Old like the oceans are old. Old like the deepest and most patient things of our own world. This light is ancient beyond our usual reckoning, and yet it is woven into the same fabric of time that carries the quiet, enduring life of our own pale blue sea. And now, let us simply marvel for a moment, because some things deserve to be sat beside rather than rushed past. Think of the journey this light has made. It left its source when the universe was barely 300 million years along, when the Earth would not exist for billions of years yet, when the sun was not even a possibility, when none of the matter that would one day become you had gathered into anything at all. It set out across the dark, a faint thread of light, and it travelled and travelled. As it went, whole generations of stars were born and died. Galaxies turned and merged. The sun ignited. The earth cooled and gathered its oceans. Life crept out of those oceans, learned to walk, learned to wonder. Empires rose and fell. Someone, somewhere, invented a way to grind glass into lenses and lift a golden mirror into the cold beyond the sky. And all the while this single ancient thread of light was still on its way, still crossing the dark, still faithful to the message it had set out with more than 13 billion years before. And then, at the end of all that travel, after a journey longer than almost anything the mind can hold, it landed, softly, on a mirror of gold drifting 1,000,000 miles from the earth. A few faint and weary particles of light gathered patiently over hours of staring, completing a journey older than the world itself, arriving at last in the one small place and the one brief moment where something was finally ready to catch them and to understand. The odds of that meeting, that gentle landing of the oldest light upon the newest eye, are almost too delicate to think about. And yet it happened. It happened, and because it happened, we know. We know that JADESGS 130 is real. This was not a guess or a fleeting smudge that might have been a trick of the light. When the telescope first found it in its images, the galaxy appeared as a tiny reddened point, a faint warm dot against the black. But a dot alone could have been many things. So the astronomers did something more careful. They took the galaxy's light and they spread it out, gently, the way a raindrop spreads sunlight into a rainbow, separating it into all its different shades. And in that spread of light, they read the unmistakable signature of enormous distance, the fingerprint that confirmed the redshift, the proof that this small reddened point truly was a galaxy seen at the dawn of time. For a while, it stood as the most distant, the oldest, the most ancient confirmed galaxy we had ever seen. A new record set in the deepest dark, but a record is the smallest part of why this mattered. Remember the rule. Remember the careful and beautiful story of how galaxies were supposed to come to be. They were meant to be slow, assembled gradually, brick by patient brick, gathered over hundreds of millions of years inside the invisible halos of dark matter. The very first galaxies, when they finally appeared, were expected to be small and faint and barely begun. Pale newborn things just learning to glow. The universe was not supposed to be in a hurry. Anything formed, anything clearly shining, anything that looked like a real and proper galaxy was meant to take its time. And yet here, only about 320 million years after the beginning, in the very window where the story expected only the faintest first stirrings, was a galaxy already formed, already shining brightly enough to send its light clear across the entire universe and still be caught, all these billions of years later, by a mirror in the cold. It existed earlier than the comfortable timeline wanted it to. It was there, glowing, in a chapter that was supposed to hold almost nothing at all. This is the first crack in the careful story. Not a shattering, not yet. Just a single fine line running through the surface of what we thought we understood. A quiet place where the universe and our explanation of it no longer quite agreed. One galaxy, found early. One small reddened point in the direction of a modest furnace, carrying a question no one had quite expected to ask. How did you get here so soon? How are you already shining, already whole, already a galaxy, in an age that was meant to be only the beginning of beginnings? Let yourself feel the gentleness of that astonishment. There is no alarm in it. The universe has simply done something we did not expect, the way a quiet friend sometimes surprises you with a depth you never knew they held. The story we wrote was careful and good and earned through long labor, and it is not wrong so much as incomplete, caught in the soft act of being revised by the cosmos itself. JADESGSZ130 is not a problem to be feared. It is an invitation, a single early light, glowing in a place it was not supposed to be, asking us, kindly, to look again. For a little while, this one ancient galaxy stood almost alone, a curiosity at the edge of the possible, a single surprising note in the deep dark. It might have stayed that way, a lovely outlier, a thing easily set aside. A single early galaxy, after all, can be explained away. The universe is vast, and rare things happen. But the golden telescope kept looking. It kept gathering the oldest light, drop by patient drop, from that small patch of sky and from others like it. And JADESGSZ130, it turned out, was not going to remain alone for very long. There was more waiting in the dark, and the records, once they began to fall, would not stop falling. A single early galaxy is a curiosity. Two is a coincidence. But as the golden telescope kept its patient watch upon the deep, the curiosities began to gather, one after another, each arriving like a soft knock at a door we thought we had already closed. And with every new discovery, The careful story did not break all at once. It simply turned another page, and then another, quietly rewriting itself in the dark. Let us meet the next of them, because it did something that the first had not quite dared to do. It broke the record. Its name follows the same gentle pattern as before, a quiet string of letters and numbers. It is called Galaxies 140, and where the first galaxy had a redshift of 13.2, this one carried a redshift of 14.32, a number larger still, a light stretched even further, drawn out across even more of the universe's long history. Translate that number softly, the way we have learnt to. A redshift of 14.32 means we are seeing this galaxy as it looked less than 300 million years after the very beginning, even earlier than the first, even closer to the dawn. We had reached back past the previous record, past JADESGSZ130, into a chapter of cosmic time that was, somehow, even younger and even more unfinished. By every expectation, this should have been a place of almost nothing, of the very faintest first stirrings, of timid newborn light barely able to glow at all. And here is where the gentle disbelief begins to mount, because JADESGSZ140 was not faint, it was not timid, it was not the pale and modest smudge the careful story demanded. It was bright, astonishingly, stubbornly bright, so bright that when astronomers first measured it, they could hardly believe what the numbers were telling them. It shone with a strength that the earliest universe was simply not supposed to be able to produce. It was too bright, too soon, and it was not only bright, it was large. When the astronomers measured its size, they found that this galaxy stretched more than 1,600 light-years across. Let us make that gentle and real. A light-year is the distance light travels in a single year, an almost unthinkable span, and this galaxy reached across more than 1,600 of them. That is not a tiny seed of a thing just beginning to gather. That is a real and substantial galaxy, broad and spread out and settled, the kind of structure that the story said should take far longer to build. It was too large, too soon. There was one more thing, and it mattered most of all. When a faint and distant point of light appears far too bright for its age, astronomers have a ready explanation that does not trouble the story. Sometimes the brightness does not come from stars at all. Sometimes it comes from a great black hole at a galaxy's heart, feeding on the matter around it, blazing fiercely as that matter falls in. A glow like that can fool you. It can make a small thing look large and a young thing look grand. So the astronomers looked carefully, hoping perhaps that this was the answer, that a hidden black hole was simply playing tricks with the light. But that is not what they found. The light of JADESGSZ140, spread out and read closely, did not carry the signature of a feeding black hole. It carried the signature of stars. Genuine, true, newborn stars, a great host of them, shining together across those 1,600 light-years. The brightness was real. The galaxy was real. It was a true island of young stars, fully and properly aglow, sitting in an age of the universe that was supposed to hold only the gentlest beginnings. Not a trick of a black hole, not an illusion. Simply a galaxy, far too bright and far too large and far too whole, far too soon. Feel how the ground begins to shift beneath the careful story. The first galaxy could be set aside as a rare and lonely outlier. But this one could not be explained away so easily. It was brighter, larger, earlier, and unmistakably made of stars. And it was not alone. Close beside it, in the same patient survey, the astronomers found another. This one they named JADESGSZ141, a sibling to the record breaker, sitting near it in the deep. Its redshift was 13.9, only a little less than its bright companion, which places it too in that astonishingly early window, only a few 100 million years after the beginning. Another galaxy, formed and glowing, in a chapter that was meant to be nearly empty. Where there should have been one surprise, or none, there were now several, clustered together in the dark, each one a quiet page turning. And notice the rhythm of it, the gentle and unsettling rhythm. Too bright, too soon. Too large, too soon. Too many, too soon. With each discovery, the same soft phrase returns, like a line repeated in a lullaby, each time a little heavier with wonder. The universe kept doing the thing it was not supposed to do, and it kept doing it again and again, calmly, without apology, as though it had never read the careful story at all. Now, let us turn to one more of these early lights, because it whispers something slightly different, something about the Dark Ages themselves. Its name is JADESGSZ131, close cousin to the very first galaxy we met. We see it as it looked around 330 million years after the beginning, deep in that early window. But what made this one remarkable was not only its distance, it was what its light revealed about the fog. Remember the cosmic dark ages, that long, quiet stretch when the universe was filled with a thick haze of hydrogen gas, opaque and muffling, a fog so dense that light could not travel cleanly through it. Remember how that fog had to lift before the universe could become clear and bright, before light could move freely across space. According to the careful story, the lifting of that fog was a slow and gradual process, taking a long time to complete, the early universe only reluctantly and unhurriedly turning transparent. But the light of JADESGSZ131 told a different tale. Its glow appeared to be burning through that hydrogen fog, piercing it, carving out a clear space around itself, at a time when the fog was supposed to be still thick and unbroken. The galaxy was shining its way through the haze earlier than the timeline allowed. It hinted that the universe had begun to clear, to brighten, to turn transparent, sooner than anyone had predicted. The fog was lifting too early. The dawn was breaking too soon. Sit with the gentle strangeness of that. It is not only that galaxies appeared too early, it is that the whole universe seems to have woken up ahead of schedule, throwing off its blanket of fog, letting its first light spill out into the dark before the careful story said it should be possible. Too bright, too large, too many, too clear, too soon, too soon, too soon. The phrase keeps returning, soft and insistent. Each repetition another small page turning in the great revision, unfolding in the deep. Let us pause here and feel where we have arrived, because something has quietly changed. When we met the very first galaxy, JADESGSZ130, it stood almost alone, a single fine crack in the surface of the story, easy to wonder at and easy, perhaps, to set aside. One early light, one lovely outlier. But now the picture is different. Now there is JADESGSZ140, brighter and larger and earlier than the first, made of genuine young stars. There is its sibling JADESGSZ141 close beside it. There is JADESGSZ131, burning through the fog before the fog was meant to lift. The single crack has become a pattern. The outlier has become a crowd. And this is the thing that astronomers cannot easily ignore. A single surprise can be explained away. The universe is enormous, and rare and unlikely things do happen now and then. And one strange galaxy might simply be a freak of chance. But when the surprises arrive again and again, when each new look into the deep brings another galaxy too bright or too large or too early, the explanation of chance begins to wear thin. A pattern is not an accident. A pattern is the universe telling you something. And what these early lights seem to be saying, gently and without alarm but quite clearly, was that they had come into being faster than the careful story believed they could. There is a particular feeling that comes over you when something you trusted begins, softly, to give way. It is not panic. Out here, in the slow dark, there is no room for panic. It is closer to a kind of widening wonder, the feeling of a familiar room revealing a door you never noticed, the feeling of the ground turning out to be deeper than you thought. The astronomers who found these galaxies felt it too. They had pointed their golden mirror at the dawn, expecting modest beginnings, and instead the dawn had answered with light upon light, each one a little too much, a little too soon, each one another quiet page turning in a story everyone had thought was finished. And remember, every one of these galaxies is real in the most patient and careful sense. These were not fleeting guesses or hopeful smudges. Their light was gathered over long hours of staring into the dark, then spread out and read closely, shade by shade, to confirm the great distances and the early times. The astronomers checked and checked again, because they knew how strange the answers were, and the answers held. The galaxies were there, formed and shining in the first few 100 million years of everything. The record fell, and then it fell again, and each falling record carried the same soft and astonishing message up from the deep. So here we rest, with the ground gently shifting beneath us. We have met a small family of impossible lights now, gathered in the early dark. JADESGSZ130, the first crack. JADESGSZ140, the bright and stubborn record breaker made of true young stars. JADESGSZ141, its near companion. JADESGSZ131, clearing the fog before its time, each one early, each one too soon, each one a page turned in the careful story of how the universe was supposed to grow. And yet, even now, there is a way to hold all of this gently. A galaxy that simply appears early is surprising, but perhaps not impossible. Perhaps the universe lit its first lamps a little sooner than we thought. Perhaps the dawn came quickly. That alone, strange as it is, might be folded back into the story with only a little stretching. But there was something else waiting in these early lights, something deeper and stranger than the question of when. Because as the astronomers looked closer at these galaxies, they began to ask not only how they had appeared so early, but how they had grown so large, so full, so heavy with stars, in so little time. And that question, the question not of timing but of substance, was the one that would press hardest of all against the careful story. We will come to it gently. For now, simply let the records fall, one after another, soft as turning pages, into the quiet dark. Until now, the surprise has been one of timing. Galaxies appearing too soon, light arriving from a chapter that was meant to be nearly empty, the dawn breaking ahead of schedule. And that alone was enough to send a fine crack running through the careful story. But timing, strange as it was, could perhaps be absorbed. Perhaps the universe simply moved a little faster than expected. Perhaps the first stars ignited sooner, the first structures assembled more quickly, and the careful timeline needed only a modest adjustment, a small nudge forward, to make room for these early lights. But now the puzzle deepens. Now we move from when to how much, and this is where the ground begins to shift in a way that is harder to steady. Because the problem with some of these early galaxies is not only that they exist too soon, it is that they are too big, too full, too heavy with stars, too finished. They do not look like things that have just begun. They look like things that have been growing for a very long time, and yet the universe has not given them a very long time in which to grow. They are, in the gentlest and most unsettling sense of the word, impossible. Let us sit with what the careful story expected one more time, because the contrast is where the wonder lives. In the standard picture, the one built so carefully over decades, galaxies assemble slowly. They begin as small, faint clumps of gas pooling inside the invisible halos of dark matter, and they grow by gathering more gas, lighting new stars, merging with other small clumps, gradually becoming larger and more complex over hundreds of millions of years. The Milky Way, our own galaxy, with its vast spiral arms and its hundreds of billions of stars, is the product of more than 13 billion years of this slow and patient work. It has had nearly the full age of the universe to become what it is. It is old and grand because it has had so very long to grow. Now, hold that in one hand, gently, and in the other, let us place something that should not be possible. There is a galaxy called ZFUDS 7329. It does not sit quite as close to the beginning as the galaxies we have already met. Its light comes from a time when the universe was roughly 800 million years old, which sounds like a long time until you remember that the universe is now nearly 14 billion years along. 800 million years is less than the first 6% of cosmic history. It is the opening few pages of a very long book. And in those opening pages, when everything was supposed to be small and unfinished and just getting started, ZFUDS 7329 was already enormous. It holds more stars than the Milky Way. Let that land softly, because it deserves to be felt rather than rushed past. Our own galaxy, with its sweeping arms and its ancient globular clusters and its hundreds of billions of suns, has had nearly the entire life of the universe to gather itself together. And here, in a galaxy that formed when the cosmos was barely begun, there are more stars than in all of that. More stars assembled in a fraction of the time. It is as though someone built a cathedral in an afternoon, every stone in place, every arch completed, while the rest of the world was still learning to stack blocks. And the strangeness goes deeper. Remember the scaffolding. In the careful story, galaxies form inside great halos of dark matter, those invisible structures that gather first and provide the gravitational framework for ordinary matter to settle into. The dark matter builds the stage. The stars and gas fill it afterward. This is fundamental to how the standard picture works. Without the dark matter halos, without that unseen architecture, The visible matter has no reason to collect in the right places, no blueprint to follow, no foundation on which to build. But ZFUD S7329 seems to have appeared before that scaffolding was fully ready. The dark matter halos at that early time were still forming, still gathering, still too young and too small to have supported the assembly of something this massive. And yet, there it is. A galaxy heavier with stars than our own, built in an era when the invisible foundations should not yet have been strong enough to hold it. It is as though the cathedral appeared before the ground was even laid, built without a blueprint, finished before the tools were ready. The astronomers who studied it did not use dramatic language. Scientists rarely do. But when they published their findings, they noted carefully that this galaxy poses a significant challenge to the standard model of cosmology. Not a curiosity, not an oddity, a significant challenge. That is the measured, cautious way a scientist says that something does not fit, that the story as written cannot easily explain what they are seeing, that the ground beneath a trusted framework has begun, quietly, to shift. And ZFUDS 7329 was not alone. It never is in this story. The impossible things keep coming in groups. Around the same time, a team of astronomers studying the early Webb images identified 6 massive galaxy candidates, 6 enormous early structures that together pressed even harder against the walls of what the careful story allowed. These 6 galaxies were seen at times between roughly 500 and 700 million years after the Big Bang, still deep in the first chapters of cosmic history, still in the era when things were supposed to be small and modest and barely underway. And each one of them weighed more than 10 billion times the mass of our Sunday. Let us make that number gentle enough to hold. The Sun is a star, a single ordinary star, one among hundreds of billions in our galaxy alone. It is vast beyond anything in our daily experience, a sphere of fire more than 1,000,000 times the volume of the Earth. And each of these 6 early galaxies contained the mass of more than 10 billion suns. 10 billion. Not scattered thinly across a great empty space, but gathered, concentrated, assembled into galaxies that were already bright and heavy and full. Some of them appeared even more massive than the Milky Way itself, despite the fact that our own galaxy has had billions upon billions of more years in which to form and grow. The Milky Way is the slow, patient, expected product of deep time, and these 6 young galaxies were matching it or exceeding it in a sliver of the time available. The contrast is almost vertigo-inducing, a quiet, falling feeling when 2 things that should not exist side by side are placed gently next to each other and allowed to speak. But the most unsettling detail was not simply the mass. It was what that mass implied about how efficiently these galaxies had converted their raw materials into stars. In the standard picture, galaxies are not perfectly efficient. They gather gas, yes, but much of that gas does not become stars. Some is heated and blown back out. Some drifts and remains unconverted. The process is messy and slow and wasteful, and that is fine, because the universe has plenty of time for waste. Under normal conditions, a galaxy might convert only a modest fraction of its available gas into stars over its lifetime. But when the astronomers looked closely at these 6 massive early galaxies, they found something extraordinary. Some of them appeared to have converted nearly all of their available gas into stars. Nearly all of it. Not a modest fraction, not half, not even most. Almost everything they had was turned into suns. It is as though they took every last scrap of raw material the universe gave them and burned through it with a speed and completeness that the standard picture simply cannot account for. Think of it this way. Imagine you were given a small pile of wood and told to build a fire, and instead of a modest campfire, you produced a blaze that consumed every last splinter, every shaving, every grain of sawdust, all at once, in a fraction of the time anyone expected. And then imagine that the fire, when it was done, was larger than fires that had been burning for 10 times as long. That is something close to what these galaxies seem to have done. They took what little the young universe could offer and turned it, impossibly efficiently, into light. The astronomer who led the study, Mike Boylan Colchin at the University of Texas, chose his words carefully when he described what these galaxies meant. If the masses are right, he noted, then we are in uncharted territory. That is a scientist standing at the edge of the known and saying softly that the map may need to be redrawn, not thrown away, not burned, simply redrawn, because the landscape turns out to be different from what the map described. And there is one more discovery to hold here, one more quiet page turning in this chapter, and in some ways it is the strangest of all. Because among the surprises of the early universe, the galaxies that appeared too soon and grew too large, there was also a galaxy that had already stopped. Astronomers found, deep in the Webb data, a galaxy from the young universe that was no longer forming new stars. It was, in the language they use, a dead galaxy. Not dead in any dramatic or violent sense. It had simply finished. It had burned through its star-forming era and fallen quiet, settling into a still and aging calm, the way a fire burns down to embers and then, eventually, to silence. In the universe as it is today, dead galaxies are not unusual. Many of the great elliptical galaxies we see nearby have long since stopped forming stars. They are old, red, quiet, their creative days behind them. But those galaxies have had billions of years in which to live out their story. Billions of years of star formation followed by a slow and natural winding down. Finding one in the young universe is something else entirely. It means this galaxy was born, built its stars, and stopped, all within the first fraction of cosmic time. It lived its whole creative life in a rush and then fell silent while the universe was still barely begun. The expected timeline had no room for this. The careful story imagined the early universe as a place of beginnings, of things just starting to ignite, not of things that had already finished and grown quiet. And yet here was a galaxy that had already completed its arc, already passed through its age of fire and settled into stillness, in an era so young that most galaxies should have barely been assembling their first scattering of stars. Let us gather all of this together now, gently, and feel the shape of where we stand. There are galaxies in the early universe that appeared too soon. That was the first surprise, the first fine crack. But now we know that some of those early galaxies were also too massive, too full of stars, too heavy, too mature, as though they had been growing for ages in a universe that had barely begun. ZFUDS 7329, with more stars than the Milky Way, built before the dark matter scaffolding was ready. 6 massive galaxy candidates, each 10 billion solar masses or more, converting nearly all of their gas into stars with a completeness that defies the standard rules. And among them, a galaxy that had already stopped, already died, already fallen quiet in the early dawn. The problem is no longer a crack, it is a pattern and the pattern says something that cannot be easily set aside. These galaxies are not merely early, they are too much, too soon, too massive, too complete, too finished, in an age that was supposed to hold only the simplest beginnings. There is a feeling that belongs to moments like this, and it is not panic or alarm. It is something quieter. It is the gentle vertigo of a story you trusted beginning to come loose. The way a knot you thought was tight slowly reveals that it was never quite as secure as it seemed. The standard model of cosmology, the careful and beautiful and hard-won picture of how the universe grew from fog to galaxies, has stood for a long time and has earned its place. But these early lights, these impossible, heavy, too soon galaxies, are pressing against it in a way that cannot be ignored. What does it mean? What must change? What new shape is the story being pulled toward, here in the quiet dark, as the oldest light in the universe delivers its strange and beautiful news? We will turn to those questions soon, gently, without rushing, because this is the kind of ground that deserves to be crossed slowly. For now, let the weight of it settle, not the weight of worry, because there is nothing to worry about in a universe that turns out to be stranger and richer than expected, but the weight of wonder, the quiet, pressing, unmistakable wonder of standing at the edge of what we know and feeling it begin softly to give way to something larger. The early universe was not supposed to be like this. It was supposed to be modest and simple and just barely beginning. Instead, it was full and heavy and bright and, in places, already done. Too much, too soon, and yet unmistakably there. So here we stand at the edge of something. Not an edge to be afraid of, not a cliff or a fall. Something more like the edge of a clearing in a deep forest, where the trees part and the view opens up, and you realize that the landscape ahead is wider and more varied than anything the path behind you had promised. The old map brought you this far, and it brought you well. But now the terrain does not quite match what was drawn, and so the map must change. This is what it means when scientists say the textbooks may need to be rewritten. It does not mean the textbooks were wrong. It does not mean the decades of careful work that built the standard model were wasted. It means that the story, as good and as tested and as deeply earned as it is, has arrived at a place where the universe is gently asking it to grow, and there is nothing frightening in that. There is, if you let yourself feel it, something close to joy, because this is the living edge of human knowledge, the place where what we thought we knew meets what we have just discovered, and the meeting is not a disaster, it is an invitation. It is the cosmos saying, softly, that there is more to learn than you imagined. Let us walk through that clearing together now, slowly, and look at the possible explanations that scientists are turning over in their hands, testing and weighing and wondering about, as they try to understand how the early universe could have produced galaxies so massive and so bright and so full, so impossibly soon. The first possibility is, in some ways, the simplest and the most approachable. Perhaps stars formed faster in the early universe than they do today. Perhaps the process of turning raw gas into burning suns was, in those first few 100 million years, more rapid and more efficient than anything we see in the cosmos around us now. To understand why this matters, think about how stars are born in the universe we know. In the galaxies we can study closely, star formation is a slow and somewhat wasteful process. Great clouds of gas collapse under their own gravity, yes, but they do so gradually, and not all of the gas makes it into stars. Some is blown back out by the fierce winds and radiation of the stars that do ignite. Some remains in diffuse clouds, never quite reaching the density needed to collapse. The whole process has a kind of built-in inefficiency, a natural drag that keeps galaxies from converting all of their raw material into stars at once. In the nearby universe, star formation is steady and measured, like a fire that burns slowly because the wood is damp and the air is still. But what if, in the early universe, the conditions were different? What if the gas was denser, more concentrated, more ready to collapse? What if the first clouds of hydrogen fell into the dark matter halos so quickly and so completely that they ignited into stars with very little waste? What if the fire in those earliest days burned hotter and faster because the fuel was dry and close and there was nothing to slow it down? If that were the case, then galaxies could have assembled their stars far more quickly than the standard picture expects, reaching enormous masses in a fraction of the usual time. The building blocks would be the same, the physics would be the same. Only the speed and the thoroughness of the assembly would be different, turned up to a level that the calm and steady nearby universe does not show us. This is a gentle revision. It does not throw out the standard model. It simply says that one of the dials, the dial marked star formation efficiency, may have been set much higher in the beginning than anyone realized. The early universe may have been a more intense and concentrated place, where the conditions for making stars were so favorable that galaxies could grow enormous in what feels, by cosmic standards, like the blink of an eye. Could that be the answer? Could it be that simple? Perhaps. But there is a complication, and it is the kind of complication that makes the story richer rather than harder. Even if stars formed faster in the early universe, the raw material still had to be there. Stars are made from gas, and the amount of gas available in any region of the early universe is determined by how much ordinary matter gathered inside the dark matter halos. And the dark matter halos, in the standard picture, were still growing, still assembling, still too small and too young to have gathered the enormous quantities of gas needed to produce galaxies as massive as the ones Webb has found. You can turn up the efficiency all you like, but if the bucket itself is too small, the fire can only burn so much. So a second possibility emerges, quiet and a little more unsettling. Perhaps there was more matter available in the early universe than the standard model accounts for. Perhaps the amount of gas that pooled in those first structures was larger than expected, or perhaps the dark matter halos themselves were more massive and more advanced in their formation than the careful simulations predicted. If there was simply more raw material to work with, more fuel waiting to be lit, then the enormous early galaxies become less impossible. They are still surprising, still ahead of schedule, but the schedule itself was based on an estimate of how much matter was available, and perhaps that estimate was too conservative. This is a deeper revision than the first. It does not just adjust a dial. It asks whether the ingredients list itself was incomplete, whether the recipe the universe followed had more in it than the one we wrote down. And if the answer is yes, then the models will need to be rebuilt, not from scratch, but with new numbers, new initial conditions, a more generous accounting of what the young cosmos had to work with. Could that be the answer? Could the universe simply have been richer in material than we knew? Perhaps, and perhaps not entirely. Because even with more matter and faster star formation, some of these early galaxies push so hard against the limits that a few scientists have begun to wonder whether the framework itself, the deep underlying structure of the standard model, might need something more than a gentle adjustment. And so we arrive at the third possibility, and it is the most thrilling and the most uncertain of all. Perhaps the standard model of cosmology, the dark energy plus cold dark matter picture that has guided our understanding of the universe for decades, needs to be modified in some fundamental way, not discarded, not thrown away, but opened up, expanded, allowed to include ideas that were once considered unnecessary or exotic. One such idea reaches deep into the nature of gravity itself. Gravity, in the standard model, behaves according to the rules set down by Einstein more than a century ago, rules that have been tested and confirmed with extraordinary precision. But some scientists have begun to ask whether gravity in the very early universe might have behaved slightly differently than it does now. Perhaps, in those first few 100 million years, the gravitational force was a little stronger, a little more eager, pulling matter together more quickly and more efficiently than the standard rules predict. Even a modest enhancement in the strength of gravity, applied across the vast scales of the early cosmos, could have accelerated the assembly of galaxies dramatically, allowing massive structures to form in a fraction of the time the standard model expects. This is not a casual suggestion. Modifying gravity is one of the most consequential things a physicist can propose, because gravity is the force that shapes the largest structures in the universe, and any change to it ripples through everything. But the early galaxies are pressing hard enough against the limits that some researchers believe this possibility deserves serious consideration. Not as an answer, not yet, but as a question worth asking. What if gravity was different at the beginning? What if the rules we know are only the rules as they are now, and the rules then were subtly, importantly, not quite the same? There is another idea, stranger still and in some ways more beautiful. Perhaps the seeds from which those early galaxies grew were not the gentle ripples in the hydrogen fog that the standard model describes, but something far more dramatic. Perhaps they were black holes, not the black holes we are most familiar with, the ones that form when massive stars collapse at the end of their lives. Those are born inside galaxies, products of stellar evolution, far too late to have seeded the first structures. The idea here is different and more ancient. Some scientists have proposed that in the very first moments after the Big Bang, in the exotic and extreme conditions of the newborn universe, black holes could have formed directly, not from dying stars, but from the raw energy and density of the beginning itself. These are called primordial black holes, and if they existed, they could have been enormous, massive enough to act as gravitational anchors around which the first gas could gather far more quickly than it would have done on its own. Imagine it this way. In the standard story, galaxies form slowly because gravity has to work patiently, pulling matter together from the faint and gentle ripples in the fog. But if there were already massive objects sitting in the early universe, great dense seeds planted in the dark from the very beginning, then matter would not need to gather from scratch. It would have something to fall toward, something already heavy and already there, a ready-made anchor that could accelerate the whole process dramatically. The first galaxies would not have had to build themselves up from nothing. They would have had a head start, a foundation laid in the first moments of everything. This is speculative. No one has proven that primordial black holes exist or that they played this role. But the idea is taken seriously because it offers an elegant answer to the deepest version of the puzzle. How do you build something so massive, so quickly, in a universe that has barely begun? One answer is that you start with a seed that is already massive, And the only way to have a massive seed that early is to have it be primordial, born not from the slow evolution of stars, but from the extreme physics of the Big Bang itself. Could that be the answer? Could the first galaxies have grown around ancient seeds of darkness, black holes born in the fire of the beginning, waiting in the fog for the first gas to fall in and ignite? Perhaps. And perhaps the answer is none of these things alone, but some combination of all of them. Perhaps stars formed faster, and matter was more abundant, and gravity was a little different, and primordial seeds helped things along, all woven together in ways we have not yet imagined. The universe is not required to have a single, simple explanation. It may be, as it so often is, more complex and more layered than any one idea can capture. What matters tonight is not which answer is right. We do not know yet, and that is perfectly fine. What matters is the feeling of standing here at this particular moment in the long history of human curiosity and realizing that the map is being redrawn. The careful story that has served us so well for so long is being tested by the oldest light in the universe, and the tests are revealing that the story may need to grow, not to be abandoned, not to be replaced with something entirely different, but to expand, to stretch, to make room for things it did not originally imagine. And there is something profoundly beautiful about that. If you let yourself feel it, there is beauty in a story that is willing to change. There is beauty in a framework that, when pressed by new evidence, does not shatter but bends, opening up new questions and new directions and new ways of understanding. The standard model of cosmology is not failing. It is being refined, the way every great scientific framework is eventually refined when instruments grow sharp enough to see what was hidden before. Newton's gravity was refined by Einstein. Einstein's picture is being tested and gently pressed by the discoveries of Webb. This is not the story of something breaking. This is the story of something growing. And what a time to be alive for it. Think of all the generations of human beings who looked up at the night sky and wondered what was out there, who built their cosmologies from myth and intuition and the slow accumulation of what the unaided eye could see. They could not have imagined a golden mirror in the cold beyond the sky, catching light from 300 million years after the beginning. They could not have imagined that their descendants would stand at a moment when the very origin story of the cosmos was being gently rewritten by the arrival of ancient photons on an instrument of extraordinary sensitivity. We are living through one of those rare and precious chapters where the map is being redrawn in real time, and there is a quiet privilege in that. Do you feel it? Not the weight of not knowing, but the lightness of it. The relief of realizing that the universe is larger and stranger and more inventive than the story we told about it. That the first chapter was not the simple, modest, unhurried beginning we imagined, but something richer and more extravagant and more full of creative urgency. That the cosmos, given barely 300 million years, was already making galaxies bright enough to be seen across 13 billion years of darkness. That the dawn was not gentle and pale, as we expected, but fierce and bright and surprisingly, wonderfully early. The textbooks are being rewritten, and they should be. That is what textbooks are for. They are not monuments. They are not sacred texts. They are the best version of the story as we understand it so far, and when the universe offers new evidence, the story changes, and the textbooks change with it. This is not a sign of weakness. It is the deepest sign of strength, the willingness to be wrong, the willingness to look again, the willingness to say, with humility and with wonder, that there is more here than we knew. What a beautiful thing it is to be uncertain. What a gift it is to stand at the edge of a clearing and see that the forest goes on further and deeper and in more surprising directions than the old trails suggested. The first galaxies are not a problem to be solved. They are a door swinging open onto a universe that was always wider and wilder and more generous than the careful story dared to guess. And as we stand here, feeling the ground shift and the map redraw itself around us, there is one more thing to hold, one more soft note to carry forward into the quiet dark, because the story does not end here. Science, real science, the patient and honest kind, does not simply propose grand new ideas and walk away. It checks, it questions, it circles back and looks again with colder eyes and sharper instruments, asking whether the surprise is as large as it first seemed, whether the impossible is truly impossible, or whether something was missed in the first breathless rush of wonder. And when the astronomers did look again, when they came back to these early galaxies with careful follow-up and new analysis, they found something that makes this story even more interesting and even more human than it already was. We will come to that next, gently, in time. There is a quality in science that does not get celebrated nearly as often as it deserves, and it is worth resting with tonight. Here in the quiet, because it is one of the most honest and most human things about the whole endeavor. Science corrects itself, not always quickly, not always gracefully. But given enough time and enough careful looking, science circles back to its own claims and asks gently whether they were right, whether the first rush of wonder might have been a little too fast, whether the numbers hold up in the clear and steady light of a second look. This is not a weakness. This is the deepest strength a way of knowing can possess. The willingness to return to a discovery, even a thrilling one, even one that made headlines and stirred the imagination, and to ask whether it is as large as it first appeared. Not out of doubt for the sake of doubt, but out of love for the truth, which is always more important than the excitement. And so, after the first wave of astonishment, after the headlines about impossible galaxies and rewriting textbooks and the edge of the known, the astronomers did what astronomers always do. They went back, they looked again, they took the data and examined it with fresher eyes and more careful methods, turning the numbers over slowly, the way you might turn a stone in a stream, to see whether the gold on its surface goes all the way through. What they found does not undo the wonder. It does not erase the surprise, but it softens it gently into something more nuanced and more true. And there is a particular kind of beauty in that softening, the beauty of a story that is willing to become more complicated rather than simply more dramatic. Here is what happened. When the first images of those impossibly massive early galaxies arrived, the astronomers measured their brightness and used that brightness to estimate their mass. This is a standard and well-tested technique. The brighter a galaxy appears, the more stars it is likely to contain, and the more stars it contains, the more massive it is. Brightness becomes a proxy for mass, a way of weighing something that is far too distant to be placed on any scale. And in those first measurements, the brightness of some early galaxies pointed to masses that were staggeringly large, the 10 billion solar masses and more that had pressed so hard against the limits of the careful story. But brightness, it turns out, can be a trickster, not a malicious one, not a liar, simply a figure that does not always mean exactly what you think it means. because there is more than one way for a galaxy to be bright. Consider what happens when a great black hole sits at the center of a galaxy, feeding on the gas that falls inward toward it. As matter spirals down into the black hole, it does not fall quietly. It heats up. It accelerates. It blazes with a fierce and concentrated light that can, in some cases, outshine the entire galaxy around it. A feeding black hole can make a galaxy look dramatically brighter than it would be from starlight alone. And if you are measuring that galaxy from very far away, from billions of light years away, using brightness as your yardstick for mass, then the black hole's glow can fool you. It can make the galaxy appear far more massive than it truly is, inflating the number, stretching the estimate, turning a moderately large galaxy into what looks like an impossibly enormous one. This is what some of the follow-up studies began to uncover. Among the very early galaxies that had seemed so impossibly massive, some of them harbored intensely active black holes at their centers. These black holes were feeding hungrily on the surrounding gas and blazing with a brightness that had nothing to do with the number of stars in the galaxy itself. When the astronomers carefully separated the light of the black hole from the light of the stars, the galaxies shrank, not to nothing, not to insignificance, but to sizes that were less extreme, less impossible, less in conflict with the careful story. There was a particular kind of early galaxy that had been puzzling astronomers for some time, and this puzzle now began to make more sense. In the Webb images, some of these ancient objects appeared as tiny, intensely red points of light, almost star-like in their compactness, glowing with a warmth and a redness that seemed out of proportion to their size. These small, dense, reddened points had been noticed and wondered about, catalogued and studied, and now a clearer picture was emerging. Some of them were not vast and sprawling galaxies at all. They were compact objects whose brightness was dominated by the fierce glow of a central black hole, a tiny blazing heart that outshone everything around it and inflated the apparent mass of the whole system. When you account for this, when you carefully subtract the black hole's contribution and measure only the starlight, the masses come down. The galaxies are still early. They are still impressively large for their age. But some of them are no longer the impossibly, universe-breakingly massive objects they first appeared to be. The crisis softens. The crack in the careful story narrows, not to nothing, but to something more manageable, something the standard model can stretch to accommodate without snapping. One of the astronomers who led this careful re-examination, Stephen Finkelstein at the University of Texas, offered a conclusion that deserves to rest gently in the air tonight. The standard model of cosmology, he suggested, is likely not broken. Anytime you have a framework that has stood the test of time for this long, you need overwhelming evidence to really set it aside. And the evidence, once examined carefully, once the brightness of black holes was accounted for and the masses were recalculated, was not quite overwhelming. It was surprising. It was fascinating. It was enough to keep everyone asking questions, but it was not enough to bring the whole edifice down. Let that settle softly, the way a leaf settles on the surface of still water. There is no crisis. The careful story, the one built over decades of observation and thought, the dark energy plus cold dark matter picture that has explained so much so well is still standing. It is tested, it is pressed, it is stretched in places where it was not stretched before, but it has not fallen. It is, for now, still the best map we have. And there is something deeply reassuring in that, something that speaks to the solidity of the work that built it. A framework that can survive this kind of challenge that can absorb the surprise of impossibly early galaxies and emerge still intact, still useful, still the most reliable guide to the deep past, is a framework that deserves our quiet respect. It was not built carelessly. It was not a guess. It was the slow and patient accumulation of evidence and reasoning, tested and retested across generations, and it has earned the right to be questioned hard and still stand. But here is the part that keeps the sky interesting, and it is the part I want you to carry into sleep tonight, because it is the most beautiful piece of all. The standard model may not be broken, but it is not perfectly at ease either, because even after the follow-up studies, even after the black hole corrections and the more careful mass estimates, there is still something left over, something unexplained, something quietly, stubbornly wonderful. There are still about twice as many massive galaxies in the early universe as the standard model predicts. Let that land gently. Not 10 times too many, not 100 times, twice. It is not an enormous discrepancy. It is not the kind of gap that shatters a framework, but it is real. It is persistent. It does not go away when you account for the black holes and recalculate the masses. Even after the most careful corrections, the early universe still seems to contain more large galaxies than the models say it should, roughly double. A quiet, stubborn excess that refuses to be fully explained away. And this is where the story becomes, to me, most tender and most true, because this is the reality of science as it is actually practiced. Not the dramatic version with its grand revelations and its clean certainties, but the real version, the one lived by the people who actually do the work. The real version is messy. The real version is full of partial answers and lingering questions and numbers that almost fit but not quite. The real version is a place where the big crisis is resolved, but a smaller, softer mystery remains. And that smaller mystery is, in its own way, just as fascinating as the crisis ever was. Think about what it means for there to be twice as many massive early galaxies as expected. It means the models are close. They are in the right neighborhood. They are not wildly wrong, but they are not perfectly right either. Something in the early universe made it a little easier, a little faster, a little more generous with the formation of large galaxies than our best simulations predict. Not impossibly so, not in a way that breaks everything, just enough to leave a gap, just enough to whisper that there is still something we do not fully understand about how the first structures came to be, and what could that something be? The astronomers have their ideas, their gentle speculations. Perhaps star formation in the early universe really was more efficient than it is today, not by the impossible factor the original mass estimate suggested, but by a more modest and more believable amount. Perhaps the first stars formed in bursts of unusual intensity, fed by denser and more concentrated gas, igniting more quickly and more completely than the steady and measured star formation we see in galaxies nearby. Perhaps the conditions of the young cosmos, its density, its temperature, its chemistry, were simply more favorable to rapid star building than the models currently capture. If that is the case, then the revision needed is not a dramatic overhaul of the standard model. It is something smaller and in some ways more interesting. It is a revision to our understanding of star formation itself, to the detailed astrophysics of how gas becomes stars in the very earliest environments. The big picture, the cosmological framework, may stand, but the smaller picture, the physics of the first fires, may need to change. This is the kind of outcome that rarely makes headlines. It is too subtle, too qualified, too full of maybes and not quites. But it is exactly the kind of outcome that real science produces, again and again, when the dust settles and the careful work is done. The dramatic version of the story is tidy, the real version is not. And the real version, with its lingering gaps and its unresolved questions, is the one that keeps scientists coming back to the telescope, night after night, looking again, asking again, because they know the story is not finished. Not everything is understood. Let those words rest in the air for a moment, because they are among the most honest and most comforting words that science can offer. Not everything is understood. There is still a gap. There is still a mystery. There is still something in the early universe that the models do not fully capture. Something about the way the first galaxies were born that remains, for now, just beyond the reach of explanation. And this is not a failure. This is why the sky stays interesting. This is why telescopes are still being pointed at the dark. This is why young astronomers are still choosing to spend their lives staring at faint reddened points of light in the deep, because they know that every answer, no matter how satisfying, opens onto a softer question just behind it. The big question, is the standard model broken, may have been answered with a reassuring, no, not quite. But the softer question, then why are there so many early galaxies, remains open, and it is pulling the science forward, gently, into territory that has not yet been mapped. Feel the tenderness of that. Feel how much more interesting the world is when not everything is resolved. A universe where every question had a clean and final answer would be a universe where there was nothing left to wonder about, and that would be, in its own way, the saddest kind of universe imaginable. The one we live in is better than that. The one we live in still holds its secrets, still offers gaps and puzzles and half-answered questions, still invites us to keep looking, keep asking, keep feeling the quiet thrill of standing at the boundary between what we know and what we do not. And so the story, tonight, is not one of crisis averted or mystery solved. It is something richer than either of those. It is the story of a careful framework that was tested hard and survived, but survived with a question still tucked inside it. A small and beautiful question about why the early universe was a little more generous, a little more eager, a little more full of light than anyone expected. The galaxies are real, they are early, they are impressive. Some of them are not quite as massive as they first appeared, but they are still there, still glowing in the deep, still more numerous than the models predict. The standard model holds, but it holds with a small, persistent, wonderful gap. And that gap is an invitation, an open door, a reason to keep watching the dark. Let your breath slow as we rest here. The sentences will grow shorter now. The pace will gentle down. The great questions are still open, and they will remain open past tonight, and past tomorrow, and perhaps past many lifetimes. And that is not something to mourn. It is something to be grateful for. The universe does not owe us a complete answer. It offers us the chance to look. It offers us the light. And the light, ancient and reddened and patient, keeps arriving, keeps landing on the golden mirror, keeps whispering its old and beautiful news. We are close to the end of our journey now. The room is quieter. The dark is softer. The great impossible galaxies of the early universe are still out there, still shining, still carrying their questions across the void. And here, in the warm and gentle present, we are still listening. That is enough. That is more than enough. We have come a long way tonight, not in miles, though the distances we have crossed are almost beyond counting, not in hours, though the light we have followed is older than anything you have ever touched. We have come a long way in understanding and in feeling, and in the quiet, patient act of wondering together about things that are larger than any single mind can hold. Let us gather the journey now, gently, the way you might fold a soft blanket at the end of a long and tender evening. We began in the dark. Do you remember the deep, warm, featureless dark of the young universe, the cosmic dark ages, when there were no stars and no galaxies and no light that could travel freely? Only a smooth fog of hydrogen drifting in every direction, patient and still, waiting for something to begin. We rested there for a while, in that ancient quiet, and we felt how peaceful the darkness was. Not empty, not frightening, simply unfinished. A universe holding its breath before the first whisper of light. We learned about the careful story that scientists had written, the standard model of cosmology, the patient and beautiful picture of how galaxies were meant to form, slowly, gradually, brick by patient brick, inside invisible halos of dark matter over hundreds of millions of years. The universe was supposed to wake up gently, to build its first structures in the most unhurried way imaginable, the way a river slowly carves a valley, the way a forest grows one ring at a time. Then we learned how to look back. We followed the beautiful idea that looking far away is the same as looking into the past, that light carries the memory of where it has been, and that the most ancient light, stretched red and then invisible by the long expansion of the universe, has been traveling toward us since the very beginning. We met the Golden Telescope, drifting in the cold 1,000,000 miles from home, built precisely to catch this ancient, reddened, infrared whisper, an eye tuned to the dawn of everything. And we felt the patience of it, gathering the oldest light one faint photon at a time, staring into the dark for hours, waiting, collecting, until at last there was enough to see by. And then the surprises came. We met Jadsgsz 130, the first impossible light, a galaxy seen as it looked only about 320 million years after the beginning, found in the direction of a modest constellation called Fornax, inside a patch of sky that had been studied for years but had never revealed its deepest secret until the right kind of eye came along. We felt the tenderness of its age, a galaxy only a little older from our view than the whole long era of sharks swimming in the oceans of Earth. We marveled at the journey its light had made, more than 13 billion years of crossing the dark, arriving at last on a mirror of gold at the one moment in all of history when something was ready to catch it and to understand. We watched the records fall. Jadsgsz 140, brighter and larger and earlier still, seen less than 300 million years after the Big Bang, stretching more than 1,600 light years across. Its light coming not from a feeding black hole but from genuine young stars, a real and proper galaxy, too bright, too soon. Jadsgsz 141, its sibling in the deep. Jadsgsz 131, whose light was burning through the hydrogen fog before the fog was supposed to lift, hinting that the universe had begun to wake and clear sooner than anyone predicted. Each discovery another page turning, each one carrying the same soft, insistent refrain. Too early, too soon, too much. We went deeper. We met galaxies that were not only early but impossibly massive, heavy with stars in an age that was meant to hold only the lightest beginnings. ZFUDS 7329, carrying more stars than the Milky Way despite having formed in the first 6% of cosmic time, built before the dark matter scaffolding was even ready to support it. 6 enormous galaxy candidates, each more than 10 billion times the mass of the Sun, some appearing to have converted nearly all of their gas into stars with an efficiency that defied the standard rules. A dead galaxy, already quiet, already finished, already past its creative age, while the universe was still barely begun. The puzzle shifted from timing to substance, from when to how much, and the careful story felt, for the first time, genuinely strained. We stood at the edge of the clearing and looked at what it might mean. Faster star formation, more available matter, modified gravity, primordial black holes acting as ancient seeds. We felt the thrill of standing at the honest edge of human knowledge, the place where the map is being redrawn, and we let ourselves feel not alarm but awe, the quiet, luminous awe of realizing that the universe is more inventive and more generous than the careful story had dared to imagine. And then we did the bravest thing of all. We looked again. We let the science correct itself, the way real science always does. We learned that some of those impossibly massive galaxies were not quite as massive as they first appeared, their brightness inflated by the fierce glow of feeding black holes at their centers, those small, intensely red points that had been puzzling astronomers for months. The masses came down. The crisis softened. The standard model, tested hard, stood its ground. Not perfectly, not completely. There are still about twice as many massive early galaxies as the models predict. A quiet, stubborn, beautiful excess that refuses to be fully explained. But the framework holds. The story survives. And the lingering gap, the gentle not quite, is not a failure, but an invitation. An open door onto the next question. A reason to keep looking at the dark. That is where we have been tonight. That is the journey. From the fog to the first light, from the careful story to the surprise, from the impossible galaxies to the humble, honest act of looking again. It is a story about the universe, yes, but it is also a story about us, about what it means to be a creature that looks up and wonders, that builds great instruments to catch the oldest light, that writes careful stories about the cosmos, and then, when the cosmos offers something unexpected, is willing to listen and to change and to find beauty in the changing. And now, gently, it is time to come home. Let the distant galaxies recede. Let the deep dark of the early universe soften and fade, the way a landscape fades when you close your eyes on a long and quiet drive. You do not need to hold any of these numbers or names. You do not need to remember the redshifts or the masses or the careful calculations. They will be here, if you want them, waiting in the quiet archive of what was shared tonight. For now, let them go. Let them drift. The way the fog of the young universe drifted, slowly and without effort, into the soft and patient dark. Bring your attention back to the room around you, to the bed beneath you, or the pillow against your cheek, or the weight of the blanket resting across your body. Feel how solid and warm and close everything is. The universe is vast and ancient and strange, and it holds mysteries that may never be fully resolved. But here, right here, in this small and gentle space, everything is simple. Everything is near. Everything is still. Notice the weight of your body. Let it be heavy. Let your arms rest wherever they have fallen, and feel how the surface beneath you holds you completely, without effort. The way the ground holds a stone. You do not need to do anything to be held. You do not need to try. Gravity, that quiet and patient force that gathered the first galaxies and shaped the whole architecture of the cosmos, is doing the same thing now, gently, with you. It is holding you down, softly, into the warm and simple place where sleep begins. Let your breath slow. You do not need to control it. Just notice it. The soft rise, the gentle fall, the pause between, where everything is still and nothing is asked of you. Each breath a little slower than the last. Each exhale a little longer. Each pause a little more complete. The galaxies of the early universe are still out there tonight. Somewhere, right now. The golden telescope is drifting in the cold, its great mirror turned toward the dark, gathering ancient light from the very edge of time. The photons are still arriving, still landing, still carrying their quiet news from the dawn of everything. And while you rest, while your breath slows and your body settles and the room around you grows dim and warm and soft, the universe is still revealing itself, one patient grain of light at a time. You do not need to watch it happen. You do not need to be awake for it. The looking will go on without you, and the discoveries will be there in the morning, and the sky will still be full of questions when you open your eyes again. If you would like another journey like this one, another slow and gentle walk through the wonders that the universe holds, there is always another video waiting for you. You can find it when you are ready, whenever that may be. There is no rush, there is no urgency. It will be there, patient and warm, whenever you want to return. And I will be here too, ready to walk beside you through whatever corner of the cosmos calls to you next. But for now, there is nothing more to do, nothing more to learn, nothing more to wonder about, at least not tonight. The wondering can wait. It is good at waiting. It has been waiting for 13 billion years after all, and it will not mind waiting until morning. Let your eyes stay closed. Let the room be dark. Let the quiet settle around you like a blanket, like the warm fog of the young universe, like the gentle, patient, unhurried dark that held everything before anything began. You are safe here. You are held. You are resting in the same universe that built those impossible early galaxies, the same cosmos that lit its first fires ahead of schedule and filled the dawn with more light than anyone expected. The same generous, surprising, endlessly creative universe that has been making beautiful and impossible things since the very beginning. You are a part of it. You have always been a part of it. And tonight, as you drift towards sleep, you carry a little of its oldest light with you, tucked gently inside the quiet of your mind. The first galaxies are still shining. They have been shining for a very long time. They will go on shining long after tonight is over. And their light, ancient and reddened and impossibly patient, will go on crossing the dark, carrying its beautiful, unanswered questions to anyone who is willing to look. But you do not need to look right now. You only need to rest. The universe will keep its wonders for you. The light will still be there. Sleep now. Sleep softly. Sleep well.